NENOMATICA, where mathematics meets YouTube excellence. We will analyze the sign of a first-degree expression that came from an image after translating the context. The model shows a profit function reading aloud, y equals 6x minus 300. X is the number of items produced, and y is the profit from sales. Our goals are to compute several sample values, find the break-even point, and decide when profit is positive or negative. Here is the model. Y equals 6x minus 300. This is the slope-intercept form. The slope is $6 per item, and the vertical intercept is negative $300, which represents the fixed cost. We are going to compute outputs for a few inputs to build intuition. Let us substitute several values of x. We will evaluate at 1, 5, 50, 100, and 1,000. To find the break-even production level, set profit to 0. So we solve 6x minus 300 equals 0. Add 300 to both sides, then divide by 6. X equals 50. Producing 50 units yields 0 profit. A quick graph helps us see the sign. Here are the axes. This line is y equals 6x minus 300. It crosses the y-axis at negative 300 and the x-axis at 50, our break-even point. Now the sign. Consider a number line for x with a marked point at 50. For x less than 50, substitute any convenient value like 0. The expression is minus 300, which is negative. For x greater than 50, the value is positive. So the profit is negative on the left, 0 at 50, and positive on the right. Summary. The linear expression y equals 6x minus 300 is 0 at x equals 50. It is negative for x less than 50 and positive for x greater than 50. The break-even production level is 50 units, and any production above 50 yields profit. In this lesson, we will analyze the sign of a first-degree expression. We will build intuition from the graph, and then work two concrete examples. A linear expression can be written as a equals ax plus b. The sign of a depends on where x sits relative to the root, which is the value of x that makes a equal 0. Solving ax plus b equals 0 gives the root x equals negative b over a. Example. Consider a equals x minus 1. Let us graph y equals x minus 1 and study where it is above and below the horizontal axis. The red point marks the root at x equals 1. To the right of 1 the graph is above the axis, so a is positive. To the left of 1 the graph is below the axis, so a is negative. Summarizing, if x is greater than 1, a is positive. If x equals 1, a is 0. If x is less than 1, a is negative. Second example, take a equals negative x minus 1. Again, we graph y equals negative x minus 1 and mark the root at x equals negative 1. For x greater than negative 1, the graph lies below the axis, so a is negative. For x less than negative 1, the graph is above the axis, so a is positive. So if x is greater than negative 1, a is negative. If x equals negative 1, a is 0. If x is less than negative 1, a is positive. Here is the big picture. Let the root be x star equals negative b over a. If it was positive, a is negative to the left of x star and positive to the right. If it is negative, the pattern flips. This completes the sign analysis for any first-degree expression. In this lesson, we will learn how to analyze the sign of a linear expression, a equals ax plus b, and then apply the method to the example 2/3 x minus 1. Step 1. Find where the expression becomes 0. Solve the equation ax plus b equals 0 to get the root x not equals negative b over a. This single point will split the number line into two regions. Now, visualize the number line. At x equals negative b over a, the expression equals 0. To the right of this point, the value of ax plus b has the same sign as a. To the left, it has the opposite sign of a. Let us work a concrete example. Take a of x equals 2/3 x minus 1. We set it equal to 0 and solve step by step. 2/3 x minus 1 equals 0. So 2/3 x equals 1. Multiply both sides by 3 to get 2x equals 3. Finally, x equals 3 over 2. Now, draw a number line for this example. Place a tick at x equals 3, halves where the expression is 0. Because the coefficient at equals 2/3 is positive, the expression is negative to the left and positive to the right of the root. We can summarize the behavior in a tiny sign table. From left to right, the expression is negative, then 0 at 3/2 and positive afterwards. Final summary. For a linear expression, ax plus b, the 0 occurs at x equals negative b over a. If it is positive, the expression is negative to the left and positive to the right. If it is negative, the pattern reverses. For our example A of x equals 2/3 x minus 1, the root is x equals 3/2. The expression is less than 0 when x is smaller than 3/2, equals 0 at x equals 3/2, and greater than 0 when x is larger than 3/2. In this example, we'll solve for x from the expression a equals negative 3x plus 7, and then build a clear sign chart to see where the expression is positive, 0, or negative. Here is the problem statement. Determine x when a equals 0 for a equals negative 3x plus 7. Then, determine the sign of the expression using a number line. Step 1. To find where the expression is 0, set a equal to 0. That gives negative 3x plus 7 equals 0. Step 2. Subtract 7 from both sides to isolate the term with x. Step 3. Divide both sides by negative 3. The negatives cancel, giving x equals 7/3. Now let's build a sign chart for the expression negative 3x plus 7. The critical point is x equals 7/3 because that's where the expression equals 0. To the left of 7/3, pick a simple test value like x equals 0. Plugging in gives 7, which is positive. To the right of 7/3, pick x equals 3. Plugging in gives negative 2, which is negative. So the expression is positive to the left, 0 at 7/3, and negative to the right. In this example, we will solve the linear expression and analyze its sign. First, show the word example. Our problem is a equals minus 3 times open parenthesis x minus 2 close parenthesis. We will follow a clean 5-step algebra path, and then draw a sign chart. Step 1. To find the root, set the expression equal to 0. Minus 3 times open parenthesis x minus 2 close parenthesis equals 0. Step 2. Use the distributive property to expand. That gives minus 3x plus 6 equals 0. Step 3. Move the constant to the right side. We get minus 3x equals minus 6. Step 4. Divide both sides by negative 3. X equals negative 6 over negative 3. Step 5. Simplify the fraction. X equals 2. Finally, we analyze the sign of the original factor. Build a small sign chart split at x equals 2. Because the factor x minus 2 is 0 at 2, the whole expression changes sign there. It is positive to the left, 0 at 2, and negative to the right, since the constant factor minus 3 is negative. Therefore, the solution is x equals 2, and the sign of minus 3 times open parenthesis x minus 2 close parenthesis is positive for x less than 2, 0 at 2, and negative for x greater than 2. In this lesson, we will determine where the expression a equals open parenthesis 3x plus 1 close parenthesis times open parenthesis x minus 2 close parenthesis is positive, negative, or 0. We will solve it using the number line sign chart method. Find the roots, split the real line, and multiply signs interval by interval. Step 1. Set the product to 0 and solve each factor. 3x plus 1 equals 0 gives x equals minus 1/3. And x minus 2 equals 0 gives x equals 2. Step 2. Build the sign chart. We align the same two cut points, x equals minus 1/3 and x equals 2 on 3 stacked number lines. The top for 3x plus 1, the middle for x minus 2, and the bottom for the product a. For the factor 3x plus 1, to the left of minus 1/3, it is negative. At minus 1/3 it is 0, between minus 1/3 and 2 it is positive, and to the right of 2 it stays positive. For the factor x minus 2, everything left of 2 is negative, exactly at 2 it is 0, to the right it is positive. Now multiply signs interval by interval to get the product a. Negative times negative gives positive on the far left. Positive times negative gives negative in the middle interval. Positive times positive gives positive on the far right. At each root, the product is 0. Therefore, a is positive on the intervals from minus infinity to minus 1/3 and from 2 to infinity. It is 0 at x equals minus 1/3 and at x equals 2. And it is negative on the open interval from minus 1/3 to 2. Recap. Find the roots. Example. We will determine the sign of the expression b equals, open parenthesis, 2x minus 3, close parenthesis squared, following the exact textbook algorithm. Make it 0, factor, solve the factors, then build a sign table. Step 1. Set the expression equal to 0. Step 2. Rewrite the square as a product with itself. Step 3. Solve each factor equal to 0. Because both factors are identical, we obtain the same root twice. Step 4. Build the sign table using the critical value x equals 3/2. The factor 2x minus 3 is negative to the left, 0 at 3/2, and positive to the right. Repeating the same row keeps the algorithmic format. Multiplying the rows shows a is positive, 0, then positive. In this short lesson, we will determine the sign of the expression a equals x times the quantity x plus 1 times the quantity x minus 1 across the entire real line. We'll find the zeros, mark a number line, then fill a clean sign chart to read the final answer. First, write the expression clearly. Now set the product equal to 0 to find the critical points where the sign can change. They are x equals -1, x equals 0, and x equals 1. Let's visualize these points on a number line. We place ticks at -1, 0, and 1. Between these ticks, the sign of the product is constant. So we will check one sample value in each region to confirm the pattern. Now, we will build a sign table. The top shows the breakpoints. The rows track the sign of each factor and the final product a. We'll fill it from left to right using the zeros we found. Start with the factor x. It's negative to the left of 0, factor x. It's negative to the left of 0, 0 at 0, and positive to the right of 0. Next, x plus 1 switches sign at -1. Finally, x minus 1 switches at 1. To get the sign of a, multiply the signs column by column. Negative times negative is negative. Zeros keep the product 0 on the breakpoints. The pattern alternates, minus 0 plus 0 minus 0 plus. Therefore, the product is negative on the interval from negative infinity to -1, and again from 0 to 1. It equals 0 at x equals -1, 0, and 1. And it is positive on the intervals from -1 to 0, and from 1 to interval from negative infinity to -1, and again from 0 to 1. It equals 0 at x equals -1, 0, and 1. And it is positive on the intervals from -1 to 0, and from 1 to infinity. Written in one line, the sign of a goes -0 plus 0 minus 0 plus as we move from left to right across the real line, plus as we move from left to right across the real line. In this example, we will determine the sign of a product with an absolute value factor, step by step, using a sign chart. Consider the expression capital P equals the absolute value of 3x plus 5 times x plus 3 times 3x minus 4 times 7x minus 4. Our goal is to find where P is positive, negative, or 0. Step 1. Set the product equal to 0 and solve each factor. The zeros come from the absolute value of 3x plus 5 equals 0, x plus 3 equals 0, 3x minus 4 equals 0, and 7x minus 4 equals 0. Remember, the absolute value term is always non-negative, and it is 0 only when 3x plus 5 equals 0. Next, place the roots on a number line in increasing order, -3, -5/3 for sevenths and 4/3. These points split the real line into 5 intervals for sign testing. We will now build a compact sign table. The columns will be labeled by, from left to right, minus infinity, -3, -5/3 for sevenths, 4/3, and plus infinity. The rows list each factor and the final product P. Here is how the signs are determined. The absolute value row is positive everywhere, with a single 0 at x equals -5/3. The x plus 3 row changes sign at x equals -3. The 3x minus 4 row changes at 4/3. The 7x minus 4 row changes at 4/7. Multiplying the signs gives the product row. Notice that capital P equals 0 at all four roots, and otherwise follows the product of signs in the intervals. From left to right, testing one value per interval confirms the overall sign of P. On -infinity to -3, P is negative. On -3 to -5/3, P is positive. On -5/3 to 4/7, P remains positive. On 4/7 to 4/3, P is negative. And finally, on 4/3 to +infinity, P is positive. We will first set A of x equal to 0. Then we will factor by grouping in a few clean steps. Step 1. Set the expression equal to 0. Step 2. Group the first two terms and the last two terms. Factor what you can from each group. Step 3. Factor out the common binomial x plus 3. Then notice a difference of squares and factor again. Step 4. Set each factor equal to 0 to find the roots. They are x equals -3, x equals -1, and x equals 1. To understand the sign of A of x, we will analyze the sign of each factor across the real line. Let's place the critical points on a number line, and then compile the signs into a tidy chart. Here is the sign chart. Columns represent the far left, each 0, and the far right. Row 1 is x. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.